technical issues. Okay, so I don't know exactly when the last video cut off, but last thing we were doing is we were evaluating this limit, and we realized from our Unit 1 Part 1 notes that technically we have to evaluate this limit from both sides, and we get conflicting entries because for here we get negative infinity, here we get positive infinity. 1 plus these infinities still is going to make us say that the limit as x goes towards -1 from the left side of this function will be negative infinity, as we see here. And then the limit as x goes towards -1 from the right side of this function will go towards infinity, as we see here. These do not equal, and the limit of x going towards -1, not from either direction, just from -1, does not exist. So 3 has the thing where we can say that the limit, or that we can't check limit as x goes towards -1 of f of x does not exist. And here we have an infinite, not infinitely, infinite discontinuity. And you can see that here in its graph representation because as we come towards this -1, that from the right-hand side we're going towards infinity, from the left-hand side we're going towards negative infinity, that split is an infinite idea. So therefore it's an infinite discontinuity. Okay, all right. Last topic of this unit is going to talk about the intermediate value theorem. So let f of x be continuous over an interval ab. If z is a real number between f of a and f of b, then there exists a number c in between a and b that satisfies that f of c will be equal to some z. So again, if it passes through a point in our spacing over here, and it's a continuous function through this particular point, then there should exist some entry that will give us anywhere or any x value that we want. And I mean, sorry, y value that we want. Technically vice versa too, right? But this is specifically in reference to looking for AC. All right. If a continuous function starts at one value and ends at another, then it must pass through every value in between. Why is that important? It helps us with roots. Roots is a point where the function crosses the x-axis, and it helps us with root finding. An intermediate value theorem can prove an equation like f of x equal to 0 has a solution in a given interval. And it also tells us that uh, existence. The intermediate value theorem tells you a solution exists even if you can't find it exactly. So the last example of this unit. Let f of x be defined as x to the power of 3 minus x minus 2. Show that f of x has a root on the interval 1 to 2. How do we do this? Well, via the intermediate value theorem, this states that we have some sort of output that can exist between this bound and this bound that's in between those two. But what are those outputs? Well, let's find that out manually. F of 1 is 1 to the third minus 1 minus 2. That's going to be -2. F of 2 is 2 to the third minus 2 minus 2. That's going to be 8 minus 4, and that's going to be 4. Okay? So that tells me that f of x has a point at x is equal to 1, y is equal to -2. And at x is equal to 2, y is equal to 4. So this tells me that even if we don't know what this looks like, which We technically could, we could graph this, right? But it's just the whole point of the example. We know that this function has no discontinuities elements to it. So we can draw any line from this point to this point. We could draw this line. We could draw this line. We can draw this line over here. But no matter what line you draw to that isn't breaking function rules, right? The index still has to be a function. We see that it will always cross this x-axis, i.e., it will always present us with a root. So it does show you that a root exists. Crosses x-axis, root exist. All right. So this is going to wrap up our Unit 1 material. After this video, I'm okay. For me, I'm probably gonna record the work sheet video, and then I'm gonna record the test 1 review video. So, I don't think it'll matter. I know, for example, the review video will go in the worksheets tab, but it will clearly be notated um as a review video. So it shouldn't be confused with the worksheet, but it does have a similar worksheet energy. So just keep that in mind. That's gonna wrap it up for today. Let me know if you guys have any questions, and I'll see you all in the next video. Bye bye.